Hey guys, today we're going to talk about end behavior and increasing and decreasing intervals within a function. End behavior describes what y is doing as x goes off toward positive and negative infinity. So it's really only concerned with what the graph is doing on the left side and on the right side. Before we can describe end behavior, we've got to see what this function looks like. So y equals 3 over x minus 5. We're going to go ahead and graph that on our calculator. 3 over x minus 5. So that's what our graph looks like. Let's go ahead and draw a sketch of that right along here at y equals 5. We're going to be approaching that from above on the right side, from below on the left side. So at y equals negative 5, we've got that line that we're approaching. So the left side looks like that, and the right side like that. When we're talking about end behavior, I really only am concerned with what's happening over here as it goes off to the left, and over here as the graph goes off to the right. So here's how we write our end behavior. As the x value approaches negative infinity, so that means as the graph goes to the left, the y value is getting infinitely close to negative 5. So the y value is approaching negative 5. Over here on the right side, x is going off toward positive infinity. As x approaches positive infinity, the y value is getting closer and closer to negative 5. So y approaches negative 5. We'll go ahead and graph our second function, x cubed minus 3x squared minus 2x plus 2. Okay, so that's what our graph looks like. And we'll put a quick sketch of it. It's not going to be perfect. It looks approximately like that. For the end behavior, I'm concerned with the left side and the right side. As this graph is going to the left, that means as the x value approaches negative infinity, the y value is going down, and it's going to continue going down forever. So in this case, y is approaching negative infinity. If on this side it did something like that and it was going up, I would still have as x approaches negative infinity because it's still the left side, but then I would put that y is approaching positive infinity. So then on the right side, as x approaches infinity, so that means as the x value is going to the right, the y value is going up, and it's going to keep going up, so the y value is approaching infinity. And again, if this thing turned and was heading downward, then I would say as x approaches infinity, because it's going to the right, it's still positive here, then since it's going down now, I would say y is approaching negative infinity. increasing and decreasing intervals. So go back to y equals and graph y equals 1 over x plus 3. We want that x plus 3 all to be in the denominator, so make sure you put in parentheses. Otherwise, it'll only keep the x in the denominator, and we'll be adding 3 outside of this fraction. So that's what our graph looks like. The y values are never going to touch 0. The x value is never going to touch negative 3. So at x equals negative 3, put that dotted line just to keep that separated. And we're talking about increasing and decreasing intervals. When we do that, we always read this graph from left to right. When the graph is increasing, that's when it has a positive slope. When it's decreasing is when it has a negative slope. So as I trace this graph from left to right, it's falling, so it has a negative slope here. So I would say that this graph is decreasing for all x values that are less than negative 3. So for x's that are less than negative 3. When I jump to the other side and trace again from left to right, it's falling, so it's decreasing again, so we have another decreasing interval. And that's for all x's to the right of negative 3, so that is for x's greater than negative 3. Go back to y equals, clear it out, and try x cubed plus 2x squared minus 8x. And graph. All right, so we're going to have a little bit of an issue here because this graph, the function actually goes off the window that I have. So I need to go to Window and go down to my y maximum. And let's try 20. Now I can see everything I need to see. So I'm going to put a sketch of that on my notes here. So it looks about like that. For this first interval, as I trace, I'm increasing until I get right here. So my first interval is an increasing interval. For x's that are to the left of that spot, so less than, unfortunately I can't tell exactly what that x value is. So what I'm going to do is calculate, find this point. That's a high point in the graph right there. So I'm going to go in the calculator and calculate a maximum. Second, and then the trace above that is calc, so second calc. And I'm going to choose option 4, maximum. You can see right here I've got a flashing cursor, and I need to get that cursor to the left side of my maximum and hit enter, and then move that cursor to the right side of the maximum and hit enter again. So between these two little arrows, it's going to calculate that maximum point. Right now it says guess. I need to hit enter, and it's going to give me that actual maximum. The x value is negative 2.43. The y value is 16.9. So this x value right here is negative 2.43. So I'm increasing for x is less than negative 2.43. Then it begins to decrease until it gets right about here. So the next interval is a decreasing interval. And it's decreasing for x's that are greater than negative 2.43, but less than whatever this x value is right here. So we need to calculate that, and that's at a low point in the graph, so that's going to be a minimum. So for this right here, I'm going to calculate a minimum. Second calc, option 3 is minimum. I want my cursor first on the left side, enter, and then on the right side, enter. So I'm going to calculate a minimum between those 2 points. So between that arrow that you kind of see a little bit there and right there, enter. And I've got my minimum. The x value is 1.097. The y value, negative 5.049. So the x value at that minimum is it's positive 1.097. So it is decreasing from x, for x is from negative 2.43 up to 1.097. And then it begins to increase again for all x's greater than 1.097. Let's end this lesson with a little bit of extra practice on end behavior and increasing and decreasing intervals. So we want to find the end behavior of this function, and we'll do so by graphing it. So we'll get our calculator out, and in y equals, we've got 7 divided by, then I want parentheses here, so x plus 3 is all part of the denominator, minus 2, and there's our graph. Okay, so we'll sketch that graph. Okay, so it looks like it's approaching a limit here on the left. So as x approaches negative infinity, which just means as the graph goes left, what is the y value doing? So the y value is approaching a limit, and what is that limit? Well, it's the same limit that we're approaching on the left side, so I'm just going to hit trace and start moving the cursor over, and it's gotten past negative 1. Looks like what it's never going to reach is negative 2, and that actually makes sense because right here it's telling me that this graph is going to shift down 2. So the y value on the left here is approaching negative 2. On the right, as x approaches positive infinity, y is also approaching negative 2 on this side. The only difference is on the left it's approaching negative 2 from below, on the right it's approaching negative 2 from above. Okay, so our next one we'll graph again. So we'll clear out y equals and type in negative 2x squared minus 4x plus 5 and graph. Okay, so this is a parabola. It looks something like this. On the left side it's going downward forever. On the right side it's going downward forever.
So as x approaches negative infinity, so that means on the left side, the y value is going down forever. It's approaching negative infinity. And on the right, as x approaches positive infinity, y is going down forever. Y approaches negative infinity. Okay, now increasing and decreasing intervals. So back to y equals, we'll clear that out. Negative 2 over x plus 4. Make sure that denominator is in parentheses, so x plus 4 is all part of the denominator. And graph. And I want a standard window here, so I'm going to hit zoom 6. So there we are in a standard window. Okay, so on this left side here, left to right, it is increasing. And then on this part here, from left to right, it's also increasing. So it's tempting to say that it's just increasing for all x. It's just always increasing. But that's not the case, because right here at negative 4, that x value doesn't even exist on this graph. So if I was to trace negative 4, I get no output. So it's not increasing at negative 4. It's doing nothing at negative 4. So I have to write two separate intervals. Okay, so I'll sketch this graph. Okay, so for x is less than negative 4, it is increasing. So I'll write increasing for x's that are less than negative 4. Okay, so that's the first interval. Then at negative 4, it's doing nothing. So the next interval, it's increasing again. And it's increasing for x's that are greater than negative 4. Okay, back to y equals for our last graph, 3x squared minus 5x minus 2. So we have a parabola. And it's decreasing until it gets right here to this minimum value, and then it's increasing. Okay, so I would say it is decreasing for x's that are less than whatever this value is right here, this x value. So I need to find the x value of this minimum. So I'm going to use the calculate option here, so second and then calculate. I will calculate a minimum, which is option 3. Okay, and it gives me a cursor, and I want to press enter on the left side of that minimum to give it a left boundary. Then press enter somewhere on the right side and give it a boundary there. So I've got a right boundary. I'm going to hit enter one more time, and I get an x value right here. So it's x's that are less than 0.8333. Okay, then it starts to increase, so it's increasing for x's that are greater than 0.8333.